my name is Maskey, Founder CEO of Fusemachines and a professor at Columbia. I've been a CEO of Fusemachines for about 5.5 years, 6 years now. I will talk about democratizing AI. So what does democratizing AI mean? But before we talk about what democratizing AI mean, like Ayush was explaining, a lot of my students at Columbia, a lot of students here, a lot of people around the world have heard this hype about AI, but still struggling to really understand what AI is. So I will first talk a little bit about AI, then I'll talk about democratizing AI, and I will talk about my journey in this democratizing AI mission. Sounds good? Sounds like everybody's interested. So what is AI? So for me, the way I would describe AI is, if you are building a machine that can take data and reason on it and decide on something that is useful for a human being, then I would call it AI. Now, that feed of data that is fed into the machine to decide on things could be different kinds of data, but particularly when I think about AI, I think about self-driving cars, right? Flying drones, talking humans. A lot of this data is perception data. The senses, 5 senses, data coming from these 5 senses. So when I say what is AI, and when people talk about AI, I think a lot of people understand it that way, which is, if a machine can take data from these 5 senses, build a reasoning on it, and decide, then it's AI. Self-driving cars is an AI. What drives AI? That's a more interesting question, I would say, right? Because we talk about AI, but what does it really drive AI? And I think even that word or that phrase or that buzzword you've heard a lot. So the thing that drives AI is machine learning. So you may ask, what is machine learning? The way I describe machine learning is a framework, or particularly a set of mathematical framework that allows a machine to build statistical models on top of data to make a decision. Right? Some of you have taken online courses, and the best example that goes on online courses is, trying to predict a housing price based on the square footage. A simple regression model, right? If the house size is 500 square feet, maybe it's 2 crore. These days, everything is expensive in Nepal, right? Real estate. And if a house is, 3,000 square feet, maybe it's 5 crore. So there is some tendency, there is some pattern on how big is the data, how big is the house, and what's the price of a house. But the same square footage of the house, right in Tamil, versus somewhere outside of Ring Road, the price is going to be different, right? So in order to build a really good decision-making system, you'd want to add another information to it. The location of it. It's in Tamil. It's in Ring Road. It's in Jamsikil. It's right here near Brigudi Mandap. So that's an extra piece of information that helps machine decide what the price should be. Right now I haven't seen any machine learning AI model to predict what the price of house should be, but there's a website called Zillow that's very heavily used in the US that you can log in, and it will tell you what should the price of that house be for every house. Every house, right? So some of those houses haven't been sold in 20 years, but how are they able to predict the price of the house? One is square footage, another is location, and there could be other things. What's the closest train station? Obviously in Nepal we don't have train station, so we may say, what's the closest distance to a bus station? Now you start thinking about it, right? So location, the square footage, is it made of concrete? That's a binary information, yes or no. Does it have a tin roof? Is it a pillar-based house? Now, as you throw in these extra sets of information or these features, you are able to make a very good machine that can do a very good prediction on what the price of the house would be. Now that's machine learning, right? And that's a simple regression model, which you can train by least square method or some other training method. And as some of you said, a lot of you already know AI, and I'm guessing a lot of you know machine learning. Now, among the buzzwords these days, besides the machine learning and AI, the other buzzword is deep learning, right? All of you have heard of deep learning, right? So I just explained a simple machine learning model, a regression model that takes a bunch of input features. You try to train the model by doing least square error, and you just get a line or a plane. Now, deep learning is just another machine learning model, just another statistical model. I think there is confusion, and I have seen among my students at Columbia as well, where they think deep learning is a completely different paradigm. But deep learning is just a subfield within machine learning. Particularly, it's just neural networks. It's just a type of algorithm like distant trees, grading, boosting trees. There's so many different algorithms, right? And neural networks is one of them. Now, if you look at the history of how neural networks came about, it started with the history of almost perceptrons. Perceptrons are just very simple linear classifiers, right, that classifies yes or no, or true and false. And it was invented quite a while ago. And then somebody invented multi-layer perceptrons, which means you're just stacking many different perceptrons. And multi-layer perceptrons are neural networks. And I have seen this confusion a lot as well. So essentially, deep learning is many, many layered neural network. And its ground, the base of it, is a bunch of classifiers built on top of it, right? And then the only difference is you are adding these non-linearities. And I'm starting to get a little too technical, but that's deep learning. So there's AI, the foundations is machine learning. Deep learning is just a different type of algorithm. And that's how you should understand it. And now you may wonder why deep learning is so popular these days. So neural network got invented quite a while ago by a bunch of professors at NYU, University of Montreal, University of Toronto, and so forth. It had its day, but one of the things that had happened, I think I would say that late 90s, was a lot of people didn't have enough computational power or data to really be able to produce good results out of neural nets. At the same time, support vector machines by Vapnik came about and it started to become very popular. But about 7, 8 years ago, Jeff Hinton and the colleagues came up with a new paper where they were successfully building these neural networks with a lot of layers to build a very interesting systems. And that's how deep learning has gotten popular. And today, deep learning has been able to beat traditional systems in many, many different problems, and that's why deep learning has become popular. I delved right into what is AI. And I thought it's a little important to sort of set the ground on how I came about doing AI. Like a lot of you, like many of you, I'm guessing many of you, I was also born here, born and raised. I went to high school here. And like everybody's parents, when I was just starting out, my mom, who was sitting right in front, wanted me to be a doctor, a medical doctor, right? And I had a chance to go as well. I did. But then I applied for colleges in the US as well. And this was 98, quite a while ago. And I got a full scholarship to a bunch of colleges. And then I had to decide. And I told my mom that when I go to the US to this college, I'm going to study a perfect combined title of field of study that would be liked by all the parents here: biomedical engineering. That's what I told my mom. I'm going to go there, I'm going to study, it's biology, medicine, engineering. It's a biomedical engineering. I'm going to study that. That's what I said. And I got to the US, and I fell in love with computers. At that time, there wasn't really internet, there wasn't a lot of network. There's obviously no Facebook. The way I applied was going to the US American Center, getting this thick Peterson's guide, going through it, finding the hardest school to get in, but that gives full scholarship and applying it, right? So I got into this college called Bates College in Maine, and I went there. And in the first year itself, I started studying computer science. I was able to build a Nepali speech synthesizer. The first one, I've claimed it's the first one, and no one has come out saying you were not the first one on it, but this was back in 2000, year 2000, right, Y2K. I built the first Nepali speech synthesizer. Then I came to Nepal in 2000, and I did a presentation at NAST. At that time, it was called RONAST, and I released the software. Nobody seemed to care. There was a bunch of people from publication. There was a small crowd. Back in 2000, AI, what AI, right? Nobody really cared. But I was doing it purely from my passion. I wanted to study AI, machine learning. So I built that. The following year, I built Nepali to English speech-to-speech translator. 2001, right? And I'm guessing a lot of you at this point who's interested in AI is trying to build things like that. More sophisticated version using deep learning probably. But at the time, just simple machine learning models where I built Nepali to English speech-to-speech translator. I got lucky by being able to work under a couple famous professors in Carnegie Mellon University, and I built the first Nepali to English speech-to-speech translator. It wouldn't translate that much, right? I was still an undergrad student back then. It would translate weather questions, time, hello, how are you, and a bunch of stuff. So that's what I did. But my interest on AI never went away. So I kept on doing research. So I further did my undergrad thesis on Nepali speech recognition system, where I built a full-fledged open domain Nepali speech recognition system. And after I did that in my bachelor's, I went and got my PhD at Columbia University. So quite a few, I think there's at least this is what I've seen in Nepal. There's a misconception that in order to get into a PhD program, you have to do master's, right? How many of you think that's the case? Not anymore, I guess. But at least a few years ago, whenever I talk to students, their first thing after they finish their bachelor's, if they wanted to go to grad school and want to do PhD, they would say, okay, I want to do master's, and then think about PhD. But you can actually directly apply for PhD programs from your undergrad. So I applied for PhD program right at the end of my third year, beginning of my fourth year, to a bunch of schools for PhD. I had no master's. It's a little harder to get in without the master's, but you can. So I got into the PhD program, got into a bunch of schools, and chose Columbia University as the place I wanted to do my PhD. And I started working on a PhD related to summarization, question answering, a lot of natural language processing systems. As I did that, I learned machine learning, I learned AI, I learned how to code, obviously, and more importantly, for a lot of machine learning things that you want to build, I learned how to do experiments. So when you're trying to build AI, it's, I would say, all about running experiments to figure out what's the best algorithm, what's the best data set, what's the best feature sets, and what's the best configuration of building a good machine learning system. Unlike building a traditional app, like an Android app or a web app or a phone app, when you are trying to build a machine learning AI system, you should think of it from the perspective of if I want this much accuracy, 95% accuracy, and 99% accuracy, right? I'm going to first get a bunch of data, decide on a bunch of algorithms, and then run a bunch of experiments, and it will produce a set of accuracy, or the results. And then you should say, okay, whatever the accuracy you got, 75%, 79%, 80%. What can I do to improve on it? And as you do it, you will realize the deficiencies in your model, deficiencies in your features, and deficiencies in your code, and so forth. And you run this iterative process to keep trying to improve the model. And then you get to a conclusion. And the beauty about PhD is there's only one metric that matters, one number. And you work for 6 years trying to improve that. So if you are doing a PhD on image classification, you're trying to build the best image classification system, right? And if you are able to beat most of the systems, you get to publish in NIPS or ACL or HLT, right? Which is one of these conferences. So that's something to understand, and I think is a useful takeaway for a lot of people who are trying to build machine learning systems is don't think of it as I will build it and it will be done. It won't be. Unless you're so good that in the first go it's 99.9% accurate, which usually does not happen. So you should sit down and say, this is going to take a long time, which is okay. This is going to be an iterative process, and I will keep building it. That's how you should look at building an AI system. So after finishing my PhD, I started working at IBM Watson for a bunch of years, where I worked on, again, a speech-to-speech translation system, at this time from English to many different languages, and question answering systems and so forth. As I did that, I learned more machine learning, more AI, got to work with the brightest minds in the world, and then after working at IBM for a couple of years, I came back to start a company and teach. Right? And this being entrepreneurship forum, I think a lot of people would be interested on particularly some of the challenges I've had and some of the successes I had while trying to build the company. You know, some of you who are trying to start companies have probably realized that you're working at some company, but there's this thing inside you that sort of making you always uncomfortable in some sense to go out and do something, right? And for me, working at IBM was a lot of fun. IBM Watson, unlike many other places, you're not really focused on product. You are focused on research, fundamental research. And when you are doing PhD, that's essentially what you do. So it's almost like a continuation of PhD. So in my last year, I spent 1 year, literally 1 year, to improve a machine translation system using deep learning by 1%. Literally 1%. 1 year, day and night. That's all I did. 1 year. And improved by 1%, and I got to publish a paper. And that's how IBM Watson research works, right? They're focused a bit more on product these days, but when you're doing research, you're essentially trying to improve that 1%. And your impact is the paper and so forth. Having worked there for almost 5 years, I wanted to go out to the world and try to do something on my own. And especially at that time, what I saw was an opportunity where I could take my skill sets and be able to apply to build a company that's quite different than the rest of the companies. So a lot of the experts in the US, here, in Europe, everywhere else, a lot of the machine learning PhDs, especially at the time, were still either in academia, teaching, being faculties, or were in big research labs doing research. Now, many of them hadn't really gone out, leave the jobs to start a company. Because, you know, starting a company comes with its own risks. You lose the salary. That's the first thing, right? So for me, I wanted to do something new and see if the machine learning skills, AI skills that I have learned over the last 15, 16 years could be applied better than other people who are trying to build an AI company. And 5.5 years ago, there wasn't as much hype as today as AI. In the last 3 years, there's a lot of hype on AI, right? A lot of hype. Everybody's trying to do AI. CEOs are mandated by boards to apply AI, even though the board might not know anything about AI. You, CEO of this company, start applying AI. CEO says, well, I got to apply AI. Here, CTO, come, apply AI. Right? That's how it goes, literally. Right? But 6 years ago, there wasn't a lot of people doing or building companies AI. So I saw an opportunity where I could use my skill set to build something different and build something useful. And that's how my journey started. And when you, as a young entrepreneur or an older entrepreneur, if you are trying to build a company, you need to find that passion that you could utilize that's inside you that would come out where you are able to apply it such that it creates a unique opportunity that everybody may not have thought about it. But in today's world, that's hard. Everybody seems to have an idea, right? Everybody seems to have an idea. But what makes a company successful is the execution side of things. Obviously, idea needs to be pretty decent, but if you talk with a lot of venture capitals in the US, and at this point, we have raised a whole bunch of VC money. So I've come to see how some of the VCs think, and what they would say is, if there are two teams coming together, and one has amazing idea, but not so good team, and if there's another team, amazing team, sorry, I mixed up. Amazing idea, not so good team, okay idea, but an amazing team. The VCs in Silicon Valley or in New York would invest on okay idea, but an amazing team. And that's because building a company is all about execution. And it's very, 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 very hard. It's very hard. And it takes a very long time. And it has its own ups and it has its own downs. And one of the things I do advise a lot of people who are trying to start a company is find a co-founder. From the perspective of ups and downs, it's brutal. And it's very, very lonely. I would say I made a mistake of trying to do it on my own. So I'm the solo founder of Fusemachines. And if I were to do it again, I would try to find a co-founder. Because the emotional toll is very, very high. And not only emotional toll is very, very high, there's just way too many things to do. So for one person to try to do so much in a limited time is difficult. Having a co-founder is not just good from the perspective of helping you emotionally while you go through these lonely nights of trying to figure out how to make the payroll, but the co-founder will also be there to share the burden of work. And particularly, if you can find a co-founder who complements your skill, then that's a perfect team. So what does that mean? That means if you are an engineer, a programmer, a coder, a developer, whatever you call it, then find someone who has a passion in sales and marketing. If you are a sales and marketing person or an MBA student, find an engineer. It's easy to say it, but very hard to do it, right? So at Columbia, when I'm teaching so I teach in both computer science department and business schools. And what I've seen is computer science students or the engineers think, well, why do I need these MBAs? I'm the one who's building it. At the end of it, it's the product, right? Without the product, there's nothing. And from what I have seen on how to do sales and marketing, I can look at a couple of videos. I can learn how to do Facebook ads. So I know how to market my stuff. So I'm just going to build stuff, right? That's what my computer science students say. Similarly, on my Columbia Business School side, students, they say, well, they need a product, but they are the lead, they are the leaders, they are the CEOs of the companies. So I just need to find a bunch of engineers, pay them some money, and have them build a product. And what I've seen is it's hard for both sides to come together to really build a company. For engineers, it's easy to build a product. For sales and marketing or MBA students, it's easy to do sales and marketing. But to really build a company, you need both parties. And that's very, very important. And that's why when you're trying to build a company, I would say try to find a co-founder with the complementing skills. Now, to talk a little bit more about my experience on trying to build a company, right? So Fusemachines got started in 2013 in US, and our first product was AI for customer service. We built a customer service automation system. And luckily, our first client was New York City government. It's very hard to sell into the government. But we managed to do presentation after presentation after presentation until we got to present to 2 deputy mayors, and they said, go ahead. And in a very small scale POC, we were able to go live with AI for customer service. So that was our first product. As we built it and we launched with the government, with the New York City website, where people would be able to ask questions related to opening businesses in New York. And after that, as we did that, we started getting some tractions. So we raised our first venture capital money from a venture capital firm in New York. Now, that's one advantage of being in the US. There's a lot of venture capital firms. And there's a lot of funds as well. From what I've seen in Nepal, there is a lot less VC firms. I think there are VC firms coming up and PE firms coming up. But there's a lot less capital that could easily be accessed to build a company. And building a company requires quite a lot of money. I mean, there is Cinderella stories that you read in TechCrunch probably, where 2 people sat in a garage, coded overnight, launched it, ran some ads, and the next day there were 2 million users. That usually never happens, right? That usually never happens. You need a proper team, and you need money to fund your activities. So we raised money from VC firm, and then that was our first round. And after that, we have done almost 4 rounds at this time of raising capital again and again and again. And particularly in the companies in the US, because there is access to capital, your focus is on growth. Your focus is not on profitability. You want to take the market and win the market and the biggest market player. And because of that, you want to grow as fast as you can. If you want to grow as fast as you can, you have to focus on growth, which means if you are focusing on growth, you need to raise more capital. And that's why you see all these news in TechCrunch, right? I mean, especially if a lot of you are tech entrepreneurs, you probably read TechCrunch and VentureBeat and so forth, where you hear, WeWork just got another $3 billion, I think, from SoftBank. Haven't been profitable. Uber, $60+ billion valuation. Haven't been profitable. And that's how a lot of startups work, because you are focused on growth and you are focused on trying to take the biggest market share. Unfortunately, in Nepal, I think I haven't really seen that concept come through yet, because there's not enough capital and there is almost a need to really try to be profitable very, very fast. And because of that, you lose out on the growth pace, and you may not become the fastest growing company and may not take the biggest market share. So that's something to think about as you build your own company in Nepal. And one of the things I would suggest is try to figure out how to raise capital. how to raise capital beyond Nepal. And these days you see the challenges and so forth, and there are 500 startups and things like that that does count for startups around the world to raise capital. And now, what I'm gonna speed up a little bit on the journey of building the company and start talking a bit more on the mission of democratizing AI. Any questions? The question is, if you think about the Nepal and AI, the question is, do we have the data? I'm going to talk about that question in more detail in a little bit in the Q&A session as well. But my short answer is no, absolutely no. We don't have the infrastructure, and we haven't set up the infrastructure, and we haven't been collecting data. And that will be one of the big challenges when we start doing AI. Okay. I will now talk about democratizing AI and how the company started doing democratizing AI. So I was talking about how we built AI for customer success, and then our second product was AI for sales, which became quite successful. And as we built it, and as we trained more engineers in Nepal, and at the same time I was also teaching at Columbia, I saw the parallels on the talent. There were quite a few students here and quite a few employees in Fusemachines who were equally capable of building some of these AI systems, like my master's students at Columbia University. Now, seeing some of this parallel, I'm not saying everybody, but there was big enough of a pool of engineers here who could do equally well. I thought maybe I should spend more time teaching some of these engineers AI. And I did that. Over Skype calls, over late night Zoom calls, over video calls, helping code, and so forth. Just going through the code itself and whatnot. And as I did that, quite a few engineers started picking up how to do AI. And that made me realize that talent is everywhere. Talent is everywhere, but what's missing is a lot of the students don't get the right set of education environment and the opportunities to be as good as students from Columbia or students from MIT and whatnot. So what if we flip it? What if we start to provide almost as good education environment, access to the professors, access to the resources, and see what happens? And with that thought, we started our mission on democratizing AI. For us, democratizing AI means bringing AI to everybody. And the way we do it is by finding talent everywhere around the world, particularly from underserved communities and developing countries, and helping them be able to build and learn AI. And our first effort on that was Fusemachines AI Fellowship, which we started last year. So in Fusemachines AI Fellowship, we would select 25 students in each cohort, and we pay for all the fees that occurs, particularly in giving exams, to get Columbia MicroMasters through EDX. When we launched the first AI Fellowship program last year, we got hundreds and hundreds of applications. They all had to give a 4-part exam, and then an interview, and we selected 25 students as the first cohort. As we started training these cohort of students, saw their progress and so forth, my thesis around talent is everywhere, they need proper access and training platform, was even more embedded in me as validity of this is the case. And as we did that, as the first cohort finished their first courses, we said, okay, this is looking good, so we should do another cohort, and now we should go beyond Nepal. And we started the fellowship program in Dominican Republic. Then we launched the fellowship program in Rwanda, and now we are launching in Burkina Faso, Peru, and so forth. So now AI Fellowship has a lot of students in multiple cohorts in many different countries, particularly from developing countries and underserved communities. And that's democratizing AI for us. Providing that access, providing that resources, providing that linkage to professors who can teach, and providing high quality resources to learn AI. As we did that, as we did multiple AI fellowship programs, we thought, well, this has become quite effective, but we are still limiting to a couple hundred students. Why not expand it even more? And with that in mind, we launched our most recent scholarship program, where we have announced that we would provide scholarship, AI scholarship, to 10,000 students around the world in the next coming years. And we recently launched, we opened the applications. We got thousands and thousands and thousands of applications. Literally multiple thousands. Multiple thousands just from Nepal, which was amazing to see, right? And we select a couple hundred students just from Nepal as the first starting program, as the first cohort, so that we have a very close tie with many different offline programs tied to the online program to learn first cohort of a couple hundred students. And we plan to expand it further as multiple cohorts of a couple hundred students roll in every couple months across multiple countries. And that's what AI scholarship is. And the hope is, as we train more and more and more AI engineers, and obviously we won't be able to hire all of them, the hope is it will create this impact on multiple layers such that even though we don't hire all the AI scholars, it will create this pool of engineers who may not work for us, but may work for other companies and may do other AI startups, which in totality will bring the overall AI research, AI product development, AI companies, and all other activities related to AI up across the whole of Nepal. And that's the motivation for it. And that's what we mean by democratized AI. And I hope all of you who are here and is interested in AI would join me in this effort to bring AI to Nepal. And bring AI to Nepal not just as a research project or just building another product, but thinking as a whole on how we can apply AI in every aspect of life. And it is starting to happen in other countries. Why cannot we do it here? I think we can. We can apply AI for image processing for detecting cancers in X-rays and CT scans. We can use drones for trying to detect probably bad crops and also spray fertilizers in agriculture. We can use long-distance drones or short-distance drones for delivering medicine. In fact, we had built one of those drones to deliver medicine. It probably will be a while before we have self-driving cars running in the roads here with that crazy traffic. But at least we can try to build some basic self-driving tempos maybe, right? Or self-driving motorcycles, I don't know. But you get my gist, right? There are many, many different applications that AI could be used here for Nepal. And many of you have realized probably that when the mobile revolution started in Nepal, even though many, many people never had computers before, they got the mobile and it transformed the economy and transformed the way we do things. And similarly, even though there has not been a full digital transformation in Nepal, we here in Nepal, we can still leap to the AI version of the world. And I'm not saying every version of AI world is good, right? There could be a lot of misuse of how AI could be used, especially one of the things that scares me the most is the use of face recognition technology and how it could be used as a surveillance mechanism, especially uh, by countries and governments who want to do mass surveillance on their citizens. There are things that could happen like that as well. I'm not saying it's happening here, but those are some of the things that that are not fun to imagine in this next version of AI world. But even though they are such scarce, I think there are also a lot of other advantages that we should look towards to build AI Nepal. And I think all of us, if we keep striving around learning AI, learning very good AI in the sense that, using very good resources and use it for good, then a lot could happen here. A lot could happen in Nepal. And I ask all of you to join me in this effort to democratize AI in the world and also in Nepal. Thank you.